Hi and welcome to this video. Today we have a WCH MCUs tutorial that I want to cover everything and you need to know about these MCUs. Plus I have a special board today from my friend mr.clooner. Mr.clooner has been made the development board for CH591R and send it to me for free. Thanks to him I can now record this tutorial and teach you everything you need to know about this MCU. So this is the board, as you can see. Let me fix the zoom. The CH591R, and here is the back. I put the description. I put the link in the description. You can buy it if you are based in Iran. And this board comes with a special LED. You can see here it's a WS2812. You can use to make your project. When you purchase this board, it will come with a default firmware that shows some of the colors to this LED. Let me show you how. As may you notice, this board has a DO and DI pins. These are for the LEDs input and output pins that you have to, you can connect to your board or just leave it as is. So this board is raw for now. I just connected some of my headers to it, and that it will come with it. If we want to make the default firmware LED work, you need the jumper wire, as you can see here, and you have to connect the DI pin to the A12 pin here. That LED will work very simply. Let me do that very quick. So yes, as you can see here, the LED starts to changing its color. The board is so cool. In the next episode of this tutorial, I will test the antenna and some of the WCH MCUs tutorial about how to make a special program like the BLE ones, but for now it's just a tutorial about how to write a program and flash it. So let me show you my laptop and where you can buy this board. As you can see, the board is available for purchase in the Leon website. So I wanna move on the desktop, that the tutorial will start there, and I will put the links in description. Make sure to check it. We are now at my laptop and we are gonna program and write a program for our MCU and flash it and see the results. So in this tutorial I will talk about the different WCH MCUs type and what's the ID to program them and how to flash the firmware. So if you are familiar with the WCH MCUs, they are a Chinese company that make cheap MCUs, mainly based on BLE and RISC-V core. Because they use RISC-V, the total cost of the MCU is very low. So I stop talking and I will teach you how to start the progress. So the first step you need to do is to download the ManRiver Studio from the manriver.com. This is the ID where it supports the WCH MCUs type that you can write your own program and flash them. You can search in your browser for ManRiver Studio or directly type manriver.com. You will come in this page and you need to hit the download button. Wait a few seconds and it will come for different architectures and operation systems to download. If you're a Windows user like me, you can choose the Windows section, and by pressing the link of here the download will start to progress. I have already downloaded the Manriver Studio and I will not download it again. After you downloaded the app, you can open it and it will ask you for some packages to download, like the SDK and compiler files. Allow it to download the needed files and you will see such a screen. Currently my Manriver Studio is on dark mode that you can probably when you download the Manriver it's light mode for you. You can go to preference and search for dark mode and you can choose different themes here based on your needs. So now we are at Manriver Studio and we want to talk about different WCH MCUs type. This is the Lyon Electronics site, a local shop in my country that has very options of WCH MCUs. Let me search for the company name and MCU section. You can see there are a lot of options for WCH and this is not all of them. If you are based on Iran and you want to test these MCUs and also want a good site to buy your parts, I recommend the Lyon Electronics. They have genuine parts, they don't sell fakes, and I recommend them. So let's talk about some of the different MCUs of this company. I want to tell there are two groups of WCH MCUs. Those are with BLE and those are with that is a normal MCU. The MCU that we are currently working with is CH591R. As you can see, it's currently here. Yes. And the mr.clooner, one of my friends, has sent me a free board development of this MCU. Let me search for it in the Lyon Electronics. You can see here. I will put the link in description, and if you want this board, I recommend it very well. mr.clooner sent me this board for free, and I tested this, and it's a genuine board with a lot of options like RGB LED. So let's back to the MCU section. As I said, you can see it's a BLE MCU version 5.4, and there are also more versions like 5.3 and 5.2. If I find them here, yes, this CH581M is a BLE 5, not 5.4 or anything else. But you can also search a global type of MCUs here like CH32V23 and CH32V33. These are general purpose MCUs that are very cheap. They don't have any BLE or RF part, but if you want to make a BLE program, I recommend these MCUs. As you can see, most of the WCH MCUs is based on RISC-V core, as mentioned here. And also they have some of their MCUs is also ARM, but most of them is RISC-V because RISC-V is free and makes the part cost less. So I talked about MCUs types. Let's move to the Manriver Studio. What we're gonna do is to download the extended package SDK of the CH591. Per default, when you open the Mount Studio, it contains the base peripheral for the MCU. But if you want to work with the BLE, you have to download an extended version of the SDK. How to do that? We have to go to the official website of the WCH. I will go into the English one, WCH.com. If I go here, you can see there are some of parts mentioned here. I will go to the Bluetooth ICs, and you can see they have also like a comparable list here. And yes, this is the MCU we're currently working with, the CH591. The series have a few options to program it. Most of the WCH MCUs have a built-in bootloader for programming that supports UART, and some of them USB, and some of them supports the SWD. And that I think that I didn't test it myself, but I think you have to purchase their programmer to work with the SWD interface. But if you want to test them, you don't need to buy the programmer at first. As you can see, we have UART pins here and also USB pins here. I will explain how to program these with these pins, so be with me. The site has been loaded, and you can see it has some of the features listed here. What I'm gonna mention here is you can see the series of the CH591. We are using the CH591R. It has a 256 kilobyte of flash and 26 kilobyte of RAM. It has BLE, of course, and one thing to mention is that this MCU doesn't have I2C. So if you want I2C, you have to buy stronger versions like CH592D. The minimum working voltage is 2.3 volt, and some of the versions is 1.7, and the package is TSSOP C16. As you can see, also Mount Studio is mentioned here. You can download the datasheet from here, and the thing we need here is the more download section. If I press that, it will go to the page to download more about this MCU. You can see here, when you came to this page, you need to download two things. First of all, the CH592. If I scroll down a little bit, we have to search more to find what I need. I don't know why it's not listed here, but there should be a zip file. Let me search for EBT. Yes, we have to search for EBT, and it will come with some of the downloadable packages. One thing that I noticed that in the global English website, you can find that extended SDK. You have to go to the Chinese version of the site, the WCH.cn, and you can by searching the CH592, you can find this file here, CH592EVT. You have to download this that I have already did, and you have to download a second thing that it's WCH ISP2 that I will explain later. That what is this file here. You have to download this file here. I have already downloaded them. So let's move on the Mount Studio again. Let me show you what's the content of this extended version of the SDK. I have downloaded the SDK here. You can see when you open the extended SDK, there will be two folders. One of them is some data sheets and explanations, And second thing is example of this MCU and its peripherals. If you want to get a description, a minimal description of each example, you can open the CH592 list EN for the English version, and it has a minimal description of each examples. Now we have the examples and also the extended version of the SDK. Why I say extended version? Because if you go to the BLE folder, there is a folder called HAL that mainly includes the codes for BLE, and there should be another folder for BLE. Without this file downloaded, you can't work with BLE at all. And yes, the lib folder, it has the ROM for BLE MCUs. It's necessary for the BLE. So also we can run one of the examples here. You can see we have ADC, BLE, Flash, and operation systems for FreeRTOS, Harmony OS, and RT-Thread, LCD, I2C, and in this case our MCU doesn't have it, UART, and USB. Also there is a source folder here that has like the extended version of the SDK needed for us, so it's very necessary to download this file. Also you can find this extended version of the SDK in GitHub if you search, I'm sure it's there. So first of all, let's work with the Mountain River Studio itself. I wanna make a new project. If I click on the file, new and Mountain River project, this page will come. It has a list for all of the MCUs that WCH has been produced. We need to find ours, and it's here, the CH591R. And also there is a minimal description here, and if we want, we can name our project. I will call it CH591R tutorial. And also the location is fine for me, and by pressing the finish, it will create the project for me. So when you have created the project, this screen will come. As you can see, there is a folder structure here that I want to explain to you. First of all, we have the link script for the MCU. You can see the RAM is mentioned here, the flash is mentioned here, and some of the regions you can change based on your needs. The next folder is related to the RISC vCore. We don't have to mess with this one, and also there's an interesting file called startup that has startup functions for the WCH MCU. Usually you don't want to change or edit these files or folders that we have nothing to do with. And the next folder is interesting. It has the peripheral code for this MCU. As you can see, like if I open the include file also, we have the header for GPIO, and the source code is also here. If you want to like read the functions is available to work, you can read this header file like GPIO-A and GPIO-B here. One thing to mention here, if you notice, these icons for these files are different from these icons in these files. What this icon means that this files is currently not included in our project. In default, when you create the project, Mountain River exclude some of the unnecessary ones for the some of the peripherals in the project, so your project doesn't get too much big. But for example, if you want to work with the SPI, as you can see the SPI is here, and the header function is already there, you can see here, but the source code, as you can see, has a red line on it, the source code of the SPI. So if you want to work with the SPI, you have to right click on it and choose include exclude from build. And if I choose that, you can see it's now came into the included version of the peripheral. So it's for the peripheral, and the final and last folder is for our main code. And this is the where you write your own codes. As you can see, we have a boring header here that I will delete them. It's a UART example for the receiving and transmitting some of data, and it's a bit complicated, but you don't usually mess with this. If I want to work with the UART, you can see first of all you need to include some of the WCH headers. We have some buffers, and we reach to the main code, main function of the SDK. So let me explain some of the functions here, and we will clean this mess up. As you can see, we have an interesting function here for the setting the clock of the MCU. Maximum clock supported on this MCU is 16 megahertz. If I open this, you can see we have some of other options like 48 and 32 and 24 megahertz. Based on your application, you can change this, and this MCU also have an internal clock source that you can use that also. So this is for the clock, and here we are setting up the GPIOs for UART. This is a general code for that you can also write for any GPIO you want to work with. If I open the data sheet here, as you can see, we have two UART pins in this MCU. One of them is RxD0 and TXD0, and the second UART is RxD1 and TXD1. If you want to program your MCU with UART option, you have to use these UART pins. But for debugging and printing and communicating with other devices, you can use also these UART pins. These are also available for use, but it's based on what do you need. So in this example, the code will configure these pins as Rx and TXD. Let me show you how. First of all, the pins are separated by A and B sections. You can see pin A and pin B, PA and PB. And so if you want to turn on the PA9 pin, you have to call the function with prefix GPIO-A. So what does this code do? So, we have to remember GPIO-A set bit GPIO pin 9. As you may notice, it's setting the bit for GPIO 9 at A section. GPIO-A 9, that the set bits mean setting the state of high, like the digital write 1 in Arduino. If you want to turn off a pin, you have to call the GPIO-A clear bit. I think I have forgot the API call, but yes, reset bit. It will equals to and digital write 0 in the Arduino. Let me show you here. I wrote this for better understanding, but as you can see, setting the high and low for the GPIO 9. So let me remove my code. As we talked, we set the GPIO pin for PA9 to 1. So the next code is GPIO mode config. What this does, if you remember in Arduino we could set a pin in input or output. This is the same. This is calling GPIO mode config, GPIO pin 9, GPIO mode output, as you can see here, with a maximum current usage of 5 milliampere. If I open this, you can see we have a few options here. We can set a pin floating. I think these are for USB, and output for 5 and 20 milliampere current. So as you can see, our PA9 is a transmit, so we have to send something. PA9 should be output, and PA8 is receive, so we have to input something, so we set it to the input. After that, we call a UART define function for the init, and our config for the UART has been done. So what if we want to send some UART data to the transmit pin? As you can see, the example is UART1 send string. You will pass a buffer or your string with its size, and it will send it to the UART. But a simpler approach is using the printf function. It's already available, and you can use this for your debugs. So this is the same as this. Let's move on to the next UART function. As you can see, there is a while that receives a string from pin PA8, and it stores it in the RX buffer, and later it sends it back to the UART. As you can see, it's like a ping pong. Whether I send to the MCU, it sends this back to me. If you want to work with the 7-bit of the UART, you have to configure your UART like this, but we don't wanna work with that. There is also an interrupt function for the UART, and that is a little bit hard to understand. You can see when it receives a string, it stores this in RX buffer, and later it sends it again to the UART. But this is the same as this code here, but this is blocking and this is not. So we understand the overall structure of the WCH MCU. Let's open one of their examples, like for the BLE. If you open the BLE folder, there are a lot of examples you can see here, but if you want a start points, I recommend the peripheral here. As you can see, there is a WV project file that if you double click on that, the example will open for you. So let me close this one for now and talk about a little bit about BLE. As you can see, this is the BLE example for this MCU. A folder structure may be a little different from what we saw earlier. As you can see, we have a profile folder here, that you can define your profile for BLE, and app for your main codes here. As you can see, there is a main file and its functions on it. For better understanding, I cleaned this architecture for myself. Let me show you quickly. In the templates, I already made the template for myself that it's easier to understand what's going on. If I open, there's only one app folder and no profile, because you set your profiles here. We have our main functions, you can see very clean, and BLE functions here. The code is same as the WCH own example, but I have cleaned it a little bit and renamed some of the files. I will upload this template for you if you want to work with that also. So as you can see here, you define your device information, and here you define your GATS profiles, like the services and the profiles. And this is the final main function for the BLE. As you can see, we have also a callback here called, I think I missed it. Yes, this is the callback function whenever the master sends the data to your MCU, you can see it will copy it into a buffer and you can work with that. It's your job to read and work with this code, and it's not part of this tutorial to how to work with the BLE, but let me quickly show you how to build your firmware. Let me back to our tutorial project. Yes. So we did example here. Now I wanna compile the projects. How to do that? It's very simple. You can choose the projects here, project menu here, and by clicking the build project, it simply we build it for you. As you can see, it's using 7 kilobytes of my flash and about 700 bytes of RAM. If you also press the F7, you can see it will build it again. It's the same. So if you notice, a new folder has been created here, OBG folder. This OBG folder contains the output for our firmware. You can see, let me open it in my folder view. There is a .hex file that this is the file we have to upload to the MCU. So after we build our firmware, let's talk about how to flash it. Do you remember the app we downloaded earlier, the WCH ISP tool? This app is responsible for programming the MCUs of different kinds. As you can see, we have RISC-V, Cortex, BLE, and some of other options. For our MCU, I have to choose the BLE MCU here. You can use like RISC-V if you have RISC-V ones. You can see there is also example. Cortex M, that is ARM MCUs, and let me close that. And this is the same section that we want to work with. As you can see here, we have some of the configuration here, the chip series, and that is already choose by 5.9 version, chip exact model, and the protocol we want to work with, whether it's USB and serial port, and there's an option for automatic download that I will talk about that later. As I said, there are different ways to program them: UART, USB, and SWD here. As you can see, TIO and TCK is responsible for SWD download. So let's move to the next part. If you notice in the datasheet, there are a section called data flash that can be used for your resources of your firmware. I mean, the code flash is for your firmware. Bootloader, you can do anything with it, but there is a data flash that you can put an external resource for your firmware here, and using code you can access it. So as you can see, there is a section for data flash file, and if you open the file browser, you can see it expects a bin file that I will explain this data flash in next episodes. The thing we want to work with is the object file 1. You can put up to 5 files to merge and upload to the MCU, but for normal usage, you only need to work with the object file one. If you open the file browser again, yes, and you have choose the hex file. We already built it in the output folder. If I choose that, it will show here, and you can see it's ready for download. One another thing that I have to mention that is unfortunately didn't mention in this datasheet. For putting the MCU into the bootloader mode, you have to do a special way. In datasheet, it's not mentioned, but pin PB22 is responsible for the boot pin. If you connect this pin to the ground and replug your MCU to the power again, it will go to the bootloader mode. As I said, you have to replug, and the reset button here will not work like the ESP that you hold the boot button and hitting the reset will enter the bootloader mode. It doesn't work like that. You have to hold the boot button and replug your MCU here. And the second thing you wanna know about this MCU. This MCU also have a second boot pin, the PB11. If you like use that PB22 in your application, you can use this for your as the second boot here. This is mentioned here. If you press the download config pin, you can see it says CH591R boot pin is PB22 and PP11. So let's move on the flashing the MCU. Let me connect the mr.clooner board to the computer, and I have to hold the boot button down for entering to the bootloader mode. As you can see, if I hold the boot button, it's identified in here the CH591 device. It's ready to flashing the MCU. If I hit the download button here, you can see very fast it's uploaded the firmware to it, and the firmware is ready. So now we flash the firmware for MCU, and now we're gonna test the results. I have connected the UART converter to the board, and RX and TX pin has been connected to the MCU. So we wanna test how the code will work. If you remember, the code was supposed to send back anything you send to it. If you like send a hi, it will send a hi back to you. I have a terminal here, that's like a terminal. I will connect to my UART converter, and I will start typing some text. Now if I send this text, I expect it to back the hi, and as you can see, it works very well. And if I text more, write more text, it's turning back every text I sent to it. Now for example, if I disconnect the TX and RX pins here, if I write some text, as you can see, nothing happens. So this was for the CH591R MCU tutorial. I wanna talk about a little bit about the CH32 MCUs, like those in here. Why I wanna talk about this? Because these MCUs has some serious information that you need to know to work with them. that even I has been fooled about them. Let me also come off the flasher. As you can see here in the WCH datasheet, I thought that this MCU can also be programmed as the UART, but the truth is it's not. The only way that you can program the CH32 MCUs is only using this programmer that which provides. You know, the programmer of the which it's really cheap, like about $5, and you can buy it easily and get your life easier. But you may get fooled, because if you look in back of the programmer, you see it says SW clock and SWIO, the exact pin number of the SWD from ARM core. But these MCUs cannot be programmed with ST-Link or J-Link, because obviously they risky core, and as it's mentioned here, the debug interface is SDI, because let me come to the pin out. You see it says SWIO and SW clock, probably here. Yes, SW clock. Don't get this wrong with the ARM's SWD, they're not compatible. The only way to program it is to purchase this flasher. But one of the cool things and interesting parts that is that you can there is some examples in the WCH SDK that you can after you flash the MCU for the first time, you can tell it to go to the UART bootloader, because it does have the UART bootloader, but the first time that you flash the MCU, you cannot access that. In the examples in-app programming, you can see it has a project template for the in-app programming, that you can also write your own custom with use UART in app programming. But these are for after the first programming, so you need to buy this programmer for the CH32, but not for the BLE MCUs like CH5 series. So this is a note that you have to notice. This tutorial has been ended. There is nothing I can talk about more. I hope this tutorial will be useful for you. Thanks for watching, and see you later.